sky has always been the ultimate high ground, but in the 21st century, the definition of altitude and speed is undergoing a radical transformation that threatens to render traditional air defense networks nothing more than expensive relics of a bygone era. For decades, the strategic advantage held by global powers relied on a delicate balance of stealth technology and missile interceptor ranges, creating a stalemate where neither side could penetrate the other's airspace without significant risk. However, the emergence of the SR-72, the spiritual and technological successor to the legendary SR-71 Blackbird, represents a fundamental shift in the geometry of aerial warfare. We are moving away from an era defined by low observable shapes and radar-absorbent coatings toward an era defined by raw, kinetic dominance. In this new reality, the primary defense is no longer hiding from the enemy, but simply moving so fast that the laws of physics prevent any countermeasure from closing the distance. This is the dawn of the Hypersonic Interceptor, a platform designed to operate in the neglected corridor of the upper atmosphere, the near space zone, where the air is too thin for conventional jets but too thick for satellites to maintain a stable orbit. At these altitudes, traveling at speeds exceeding Mach 6, the SR-72 becomes a ghost, not because it is invisible, but because it is untouchable. Current anti-aircraft systems, including the most advanced integrated defense networks utilized by modern superpowers, are built on the assumption that incoming threats will behave within certain aerodynamic limits. These systems rely on a sequence of detection, tracking, and interception that requires a specific window of time to calculate an intercept vector. When a vehicle moves at Mach 10, that window of time effectively disappears. By the time a ground-based radar array completes a single rotation and confirms a track, the SR-72 has already traveled several miles. The latency in command and control systems becomes a fatal flaw. This is the strategic speed gap that changes everything. While much of the world has focused on developing hypersonic glide vehicles that are launched from ballistic missiles, the SR-72 represents a far more versatile and terrifying capability. A reusable air-breathing platform that can take off from a standard runway, accelerate to hypersonic speeds, execute a mission, and return to base. This capability creates a permanent state of unpredictability for any adversary. Traditional defense doctrines are based on the ability to deny access to specific geographic bubbles, but when an interceptor can cross an entire continent in less than an hour, the concept of a protected zone becomes an illusion. The psychological impact of such a platform is just as significant as its technical specifications. It forces a complete reassessment of what it means to be secure in the modern age. If the most sophisticated missile batteries on the planet cannot reliably lock onto or lead a target because it is moving at 2 miles per second, then the very foundation of 20th century deterrence begins to crumble. This transition into the hypersonic regime isn't just a marginal improvement in aviation. It is a leap comparable to the move from propeller planes to the first jet engines, fundamentally rewriting the rules of the sky. The engineering heart of the SR-72 is not merely an evolution of existing propulsion, but a revolutionary departure from everything we understood about atmospheric flight. To achieve speeds in excess of Mach 6 and potentially reaching the Mach 10 threshold, the aircraft must solve the most difficult puzzle in aerospace history: the propulsion gap. Traditional turbojet engines, even the most advanced ones found in modern fifth-generation fighters, are physically incapable of functioning at hypersonic speeds because the incoming air moves too fast for the rotating blades to process, leading to a catastrophic buildup of heat and pressure. Conversely, scramjets, or supersonic combustion ramjets, are remarkably efficient at high speeds but produce zero thrust at a standstill, meaning they cannot take off from a runway on their own. The solution lies in a complex system known as the Turbine-Based Combined Cycle. This integration essentially marries a high-speed turbine engine with a dual-mode ramjet through a shared inlet and nozzle. As the aircraft accelerates, a sophisticated series of bypass valves and moving geometry within the engine nacelle redirects the airflow, transitioning the workload from the turbine to the ramjet as the speed climbs past Mach 3. This seamless handoff is the holy grail of hypersonic flight, allowing for a platform that is both recoverable and reusable, unlike the single-use hypersonic missiles that currently dominate the headlines. Beyond the engine, the structural integrity of the airframe must contend with the brutal reality of aerothermodynamics. At Mach 10, the friction between the air molecules and the leading edges of the aircraft generates temperatures exceeding 2,000 degrees Celsius, enough to melt conventional aluminum, or even the specialized titanium alloys used in the original Blackbird. This necessitates the use of advanced ceramic matrix composites and active cooling systems, where the aircraft's own fuel is circulated beneath the skin of the wings to absorb heat before being injected into the engines to be burned. This dual use of fuel as both a propellant and a coolant is a masterpiece of thermal management. Furthermore, the flight control systems must operate with a precision that exceeds human capability. At such velocities, a minor deviation of even 1 degree in a control surface could result in structural failure or a massive change in trajectory. The SR-72 must rely on artificial intelligence and high-frequency sensors to make thousands of micro-adjustments per second, maintaining stability in the thin, volatile air of the stratosphere. This creates a vehicle that is effectively a flying supercomputer, capable of navigating the complex transition from subsonic to hypersonic flight while managing a heat signature that glows like a star in the infrared spectrum. Yet, even with that intense thermal signature, the sheer speed remains the primary defense. It creates a paradigm where the kinetic energy of the platform itself becomes a form of armor. This technological leap forward represents a massive investment in materials science and computational fluid dynamics, pushing the boundaries of what is possible within the atmosphere and setting a new standard for global reach that will dictate the future of aerospace engineering for the next 50 years. The sheer complexity of managing such intense energy states while maintaining a reusable airframe is what separates this project from anything that has come before, marking a definitive end to the era of subsonic dominance and beginning the age of the hypersonic cruiser. The shift in global power dynamics is increasingly defined by the ability to penetrate the most sophisticated anti-access, area denial, or A2KAD zones. And this is exactly where the SR-72 creates a massive technological mismatch. For the last 2 decades, the consensus among military theorists was that the era of manned or even unmanned high-altitude penetrators was over, replaced by stealth drones and long-range standoff missiles. However, the development of modern ultra-long-range radar systems like the Resonance NE and the integration of multispectral tracking networks have begun to strip away the advantages of traditional stealth. If an aircraft relies solely on its shape to hide, it eventually becomes vulnerable to low-frequency radars or infrared search and track systems. The SR-72 changes the equation by prioritizing speed as its primary survival mechanism, rendering the entire concept of an interceptor missile's no-escape zone obsolete. When we analyze the performance of the S-400 or the newer S-500 systems, we see missiles designed to intercept targets traveling at several times the speed of sound. However, these interceptors are bound by the laws of aerodynamics. As they climb into the thinner atmosphere to reach a high-altitude target, their control surfaces become less effective, making it nearly impossible to maneuver against a target moving at Mach 6 or higher. The SR-72 operates in a sweet spot of the atmosphere that is too high for most tactical surface-to-air missiles and too low for exo-atmospheric interceptors designed to hit ballistic missiles in space. This creates a massive gap in the defensive architecture of any modern adversary. Furthermore, the time-sensitive nature of modern conflict means that the value of information decays rapidly. A satellite might take hours to reposition over a point of interest, and its predictable orbit makes it easy to hide from or even target with anti-satellite weapons. The SR-72, conversely, offers what experts call responsive persistence. It can be launched on short notice, arrive over a target on the other side of the globe in under an hour, and provide a high-resolution, multi-sensor look at a situation that a satellite simply cannot match. This capability effectively nullifies the mobile nature of modern missile launchers and command centers. If an adversary moves a mobile Iskander or Yars launcher, they traditionally rely on the window of time between satellite passes to relocate and hide. The hypersonic speed of the SR-72 closes that window permanently. The platform essentially acts as a giant vacuum cleaner for electronic and signals intelligence, sweeping up data at speeds that prevent the enemy from successfully implementing emission control protocols. By the time the signal is detected and the order to shut down transmitters is given, the SR-72 has already recorded the data and moved hundreds of miles away. This creates a strategic environment where the very systems designed to protect national borders the vast radar networks and missile batteries, become secondary to the sheer, unstoppable momentum of a hypersonic platform. It is a fundamental reassessment of the value of geography, where distance is no longer a shield and time is no longer a luxury, effectively placing every high-value asset in an adversary's inventory within the immediate reach of a single, uncatchable platform. The true genius of the SR-72 platform lies in its role as the ultimate sensor fusion node, a capability that transcends simple photography and enters the realm of real-time multi-domain dominance. While the public often focuses on the breathtaking speed of Mach 10, the real strategic value is found in the sophisticated suite of sensors that can operate effectively behind a wall of plasma. When an object travels at hypersonic speeds, the air around it becomes ionized, creating a sheath that typically blocks radio waves and traditional communication signals. To overcome this, the engineering behind the SR-72 incorporates revolutionary window materials and signal processing algorithms that allow its synthetic aperture radar and electro-optical sensors to peer through the thermal haze with crystal clarity. This allows for the collection of high-fidelity data from an altitude that provides a wide-area perspective while maintaining the resolution typically associated with low-flying drones. This unique vantage point is critical for modern electronic warfare. The aircraft is designed to act as a massive, high-speed vacuum for electromagnetic emissions, capturing the unique digital fingerprints of enemy radar systems, communication nodes, and command structures before they can be encrypted or moved. This data is not just stored, it is processed via onboard edge computing and can be beamed back to theater commanders via high-bandwidth satellite links. The ability to perform persistent surveillance in a highly contested environment where satellites are vulnerable and stealth aircraft are too slow is a total game changer. Furthermore, the modular nature of the internal payload bay suggests that the SR-72 is not limited to just observation. It can serve as a high-speed communications relay, bridging the gap between naval fleets and ground forces when traditional satellite networks are jammed or compromised. This ensures a continuous flow of information, maintaining the integrity of the kill chain in the most demanding scenarios. In terms of intelligence, the SR-72 provides what is known as actionable persistence. Because it can loiter in the general vicinity of a theater and return to any specific point within minutes, it can track mobile targets with a level of continuity that orbital assets simply cannot provide. This creates a state of constant visibility over an adversary's most sensitive assets, from mobile ballistic missile launchers to hidden logistical hubs. By integrating artificial intelligence into the sensor suite, the platform can automatically identify anomalies and prioritize high-value targets without human intervention, reducing the time from detection to decision to a matter of seconds. This level of technical sophistication means that the SR-72 is more than just a fast jet. It is the backbone of a new era of information warfare, where the side that can see the furthest and move fastest wins before a single conventional shot is even fired. The synergy between hypersonic transit and real-time data processing ensures that no move on the global chessboard goes unnoticed, effectively stripping away the shroud of secrecy that modern mobile defense systems rely upon for survival. The platform's ability to operate with such precision while subjected to the most extreme physical forces imaginable is a testament to the convergence of advanced materials science, high-speed computing, and visionary aerospace design, all working together to ensure that the sky remains the ultimate source of strategic clarity. The integration of offensive capabilities into a hypersonic air-breathing platform represents a paradigm shift in the concept of global strike and strategic deterrence. While the original Blackbird was purely a reconnaissance tool, the SR-72 is envisioned as a dual-purpose platform capable of delivering high-speed strike weapons with surgical precision. At Mach 10, the kinetic energy alone becomes a revolutionary force multiplier. To put this into perspective, an object traveling at such speeds possesses so much latent energy that it does not necessarily require a conventional explosive warhead to achieve its mission objectives. The mere impact of a solid, high-density projectile released from the stratosphere at hypersonic velocity can penetrate deep into hardened underground facilities that are otherwise immune to standard cruise missiles. This introduces the concept of prompt global strike, where a target can be neutralized within a time frame that renders traditional defensive responses irrelevant. The engineering challenge of deploying a payload at these speeds is immense, requiring specialized bays that can open and release instruments without disrupting the delicate aerodynamic balance of the aircraft or causing structural failure due to the sudden change in airflow. This is where the synergy between the aircraft and its internal systems becomes critical. The munitions themselves must be designed to withstand the same extreme thermal and pressure environments as the carrier aircraft, utilizing their own miniaturized scramjet engines or specialized glide bodies to maintain velocity after release. This capability creates a massive tactical advantage by compressing the time-sensitive target window. In modern scenarios, high-value mobile assets often move between hidden locations, leaving only a small window of exposure. Conventional assets, such as carrier-based aircraft or subsonic cruise missiles, may take hours to reach a location, by which time the target has vanished. The SR-72 reduces this response time to mere minutes. Furthermore, the use of kinetic energy as a primary mechanism of action offers a cleaner alternative to traditional heavy bombardment, focusing the energy entirely on the specific coordinate with minimal collateral impact on the surrounding environment. This precision is guided by advanced inertial navigation systems coupled with real-time satellite updates, ensuring that even at several miles per second, the margin of error remains negligible. The presence of such a platform in a nation's inventory serves as a powerful deterrent, signaling that no distance is too great and no defense is too robust to provide a sanctuary for high-value strategic assets. By combining the speed of a ballistic missile with the maneuverability and reusability of a traditional aircraft, the SR-72 bridges the gap between atmospheric flight and space-based capabilities. This creates a new tier of strategic competition, where the objective is not just to have the most powerful tools, but to have the fastest and most responsive ones. The ability to reach any point on a continent in less than an hour and deliver a decisive result completely rewrites the playbook for regional stability and global security, moving the world into a future where velocity is the ultimate arbiter of strategic success and the traditional boundaries of time and space are effectively erased. The long-term implications of hypersonic aviation extend far beyond the immediate technical achievements of a single airframe, signaling a fundamental restructuring of the global aerospace hierarchy and the very nature of technological sovereignty. As the SR-72 moves from the shadows of secretive development into the reality of operational deployment, it establishes a new benchmark for what defines a modern superpower. We are witnessing the beginning of a second great age of flight, one where the boundaries between the atmosphere and space become increasingly blurred. This transition forces every other nation to decide whether to invest billions in attempting to track the untrackable or to embark on their own high-risk development programs to achieve parity in the hypersonic regime. The economic and industrial ripple effects are profound, as the materials science required to survive Mach 10, ranging from advanced carbon-carbon composites to self-healing ceramic skins, will eventually find its way into the civilian sector, potentially revolutionizing everything from satellite launches to ultra-fast commercial transport. This is not merely an arms race in the traditional sense, it is a race for the mastery of extreme physics. The strategic stability that defined the late 20th century was built on the predictability of movement and the reliability of early warning systems. The introduction of a reusable Mach 10 platform introduces a level of uncertainty that current diplomatic and defensive frameworks are not yet equipped to handle. When the time to respond to a strategic shift is reduced from hours to seconds, the entire philosophy of deterrence must be updated for a high-frequency world. Furthermore, the SR-72 serves as a precursor to a future where autonomous systems take a leading role in the most hazardous flight envelopes. At these speeds, the human physiological limit is reached long before the mechanical limit of the aircraft, suggesting that the future of hypersonic dominance lies in the seamless integration of artificial intelligence with high-performance hardware. The data gathered by these platforms will feed into global networks, creating a digital twin of the entire planet's movements in real time. As we look toward the 2030s and beyond, the legacy of the son of Blackbird will be measured by how it forced the world to rethink the value of distance. In a world where no point on Earth is more than 90 minutes away, the concept of regional isolation becomes a relic of the past. The mastery of the hypersonic corridor ensures that the sky remains the most critical domain for ensuring global security and transparency. The evolution of this technology represents a definitive pivot toward a future where the ability to see, reach, and react with near instantaneous speed is the ultimate currency of influence. It is a bold leap into the unknown, reaffirming that in the quest for the horizon, those who can command the highest speeds will always dictate the terms of the era. The silent, glowing streak of a hypersonic interceptor across the edge of space is the final word in a century-long conversation about the limits of human ingenuity and the relentless pursuit of the ultimate high ground. This era belongs to the swift, the precise, and the technologically fearless, as the stratosphere becomes the new arena for the most sophisticated dance of engineering excellence ever conceived by man.